Hello friends, this is Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University, and this session relates to algorithms and flowcharts. In the last session, when we discussed about problem solving, we discussed about that there are 6 steps to solve a problem, and we identified that steps are in fact understanding of the problem, formulation of the model, development of an algorithm and flowchart, writing the program, testing the program, and evaluating the solution. In the last session, we understood that how to identify a problem and what are the various kinds of problem, and we tried to solve different type of problems which are having single type of solutions or multiple type of solutions. In this session, we will try to understand how to formulate a model and to develop an algorithm or a flowchart. The basic requirement is to firstly understand that computer information processing model is thoroughly followed in any program development, be it at the analysis stage of that program, which includes the algorithm designing and development, and the computer information processing model includes 3 stages. One is your input, second is processing, and third is your output. What kind of input you are supposed to identify that what type of input is relevant in fact to be processed, and the processing of that input leads to a proper output. So, computer information processing model in fact lays the basic formulation of the problem solution. So, let us understand this by an example, that suppose we are supposed to find average of the marks of all the students in a class. Now, in order to find the average of the marks of students in a class, you are supposed to input marks of all the students, and then the input is to be processed, that is all the marks are required to be added and they are to be divided by the number of students, and this processing actually provides us the average marks, and this average is actually communicated as an output, which could be taken as an as a screenshot or a solution on a printer or a programming output, whatever you may like to feel. So, there are 3 phases, that is input, processing, or output. Now, let us understand this problem in a much better manner, that this is the formula in fact, that average is equal to x1 plus x2 plus x3 up to xn divided by n, and this average can be mapped onto the scale of say 100 from 0 to 100. But what if the marks are given in the form of the grades? Then can we find the average? Say the grades are given to the students like B, C, A plus, F, D or whatever. Then I think this formula of x1 plus x2 plus x3 up to xn divided by n, where x1, x2, x3 up to xn are marks of the students and divided by n, that is total number of students, will not work. So, that means thinking is required. So, what could be the possible solution? In order to solve this problem, you are supposed to formulate a model. That means you are supposed to give some marks, some ranking to the different grades. Likewise, say 12 ranks or 12 points are given to A plus grade, 11 points to A grade, and 10 points to A minus grade, and so. So, you can categorize these grades. Now, the students are having different grades. Now, you can map those grades. Say a student has got A1 grade, and then A plus grade, and B plus grade, and C plus grade. So, you want average grade. So, that A plus is mapping to 12 points, B plus is mapping to 9 points, and C plus is mapping to 6 points. So, 9 plus 6 is 15 plus 2, that is 17, and 27 by 3. So, 27 by 3 is 9. So, that means the overall average grade turns out to be B plus. So, that means you are formulating a model to map the grades into the average marks. So, this type of transformation, this type of understanding is required to transform the actual system of average calculation to the calculation of average grades. Now, this processing part actually relates to the algorithm. This diagram actually relates to that there is a set of rules to obtain the expected output from the given input. So, these set of rules are actually formulating an algorithm, that is some input is given and this input is processed by the set of rules, and based on the set of rules some output is coming out which is being delivered as an output, and this is directly mapping to your computational model which includes input, processing and output. Now, what is an algorithm? So far as the formal definition of algorithm is concerned, it is a precise sequence of instructions to solve a problem. But many a times if we go to the higher levels, there are complex algorithms which are considered as randomized algorithms and non-deterministic algorithms, where the instructions are not necessary in sequence and may not be of finite number of instructions. But these algorithms are out of scope of this discussion. So, we will only discuss about the precise and the basic definition of the algorithm, that is a sequence of instruction of solving a problem. So, we will try to solve this problem and relate it to the understanding of the definition of the algorithm. Say the example is to determine the area of a circle of radius r. So, firstly understanding the problem that you want output as an area and input is the radius. So, input of the algorithm should be the radius of the circle and expected output is area. The algorithm is that you need to process this input radius by using the formula area is equal to pi r square. Now, applying this formula, you get this result into a variable area which is printed as an output. So, the formulation of the problem, that is the processing part of the problem, relates to area is equal to pi r square, and this calculation is involving a radius as input and multiplication leads to the output area. So, this is how the algorithm for calculation of area is worked out. So, algorithm has got some characteristics that it should have a well defined input, it should have a well defined output, there should be finite number of steps, and algorithm should be language independent, and all steps should be clear and unambiguous, and the algorithm should be feasible. So, these 6 are in fact the characteristics of the algorithm, that you should have well defined input and output, there should be finite number of steps, it should be language independent, and the algorithm should be clear, that is the steps of solving the problem should be clear and unambiguous, and it should be feasible. So, this representation of the algorithm actually is conveyed in two ways. One is through text and other is through symbols. The textual content delivery of algorithm is in fact referred as pseudocodes, and whereas the symbolic representation of algorithm is referred as flowchart. So, algorithm is actually a set of steps which is required to solve a problem, and that set of steps can be represented either in a textual manner, which is represented as pseudocodes, and through symbols, that is represented as flowcharts. Now, you would like to firstly understand that what is the difference in between algorithm, pseudocode and flowchart. That algorithm is in fact a well defined sequence of steps that provides solution to a given problem, but pseudocode is in fact a programming like structure. It is a mixed structure, it is a textual structure which specifies the steps of algorithm using essentially natural language or superimposed control structure. Likewise, we are using if else construct and different programming constructs into our pseudocodes. Whereas the flowchart is a traditional graphical tool with standard symbols. We will be discussing about this different type of symbols which are involved in flowchart, and these symbols are actually arranged in a sequential manner to show the flow of the sequence of an algorithm. So, flowchart and pseudocode are having different pros, advantages and disadvantages. Likewise, the flowchart can be standardized and it is quite visual, whereas the advantage of pseudocode that it can be easily modified and it implements the structured concept and done easily on the word processor. But there are some disadvantages, that the flowchart is very hard to modify because the symbolic representation is clear and very specific. You cannot alter it by just changing the text. So, that means this you cannot modify flowchart in a simple manner. So, it represents, but the pseudocode has got a disadvantage that it is not visual. You are supposed to read in between the lines that what each line is actually saying about. Apart from this, the different disadvantage of flowchart is that it has structured design and elements are not implemented. So far as the pseudocode disadvantage is that it is not accepted standard. So the accepted standard, that is, a flowchart is having a hand above the pseudocode. So in this session we will be discussing about the algorithms and the flowcharts. We will be focusing on these two techniques of solving a problems. So we understood that it is a graphical representation of a computer program. So that means it can directly map, it can directly relate to the programming instructions. So flowchart is a diagrammatical representation of the sequence of the algorithm, and it directly relates to the computer programs. And these are some of the symbols of the flowchart. Likewise, an oval, that is an ellipse, is in fact representing the starting and stopping state of the flowchart. A parallelogram is representing the input and output state, whereas the rectangle is representing the processing state of a flowchart, and a rhombus or a diamond shape is representing the decision stage. There are arrows which are representing the flow of controls, and there are connectors which are represented as circles. The connectors are required when flowchart is quite big in size. So if it is going from one page to another page, or you need to have a connectivity, so connectors are required. So what is the need of a symbol? So there is some funny example is used over here to understand what is the need of the symbol, why we are having different symbols for starting, stopping, processing, and taking decisions or so. So let us take a problem that does the thing work, and you say yes, and you don't mess with it, and it stops. And if the thing is not working and you are asked that you did some mess with it, and that means you are going into a state that you are stuck up and you should not have done. So these multiple decisions are being discussed over here for solving a problem. But none of the symbols, all of the symbols are in fact rectangles, and because of these we are not able to identify that which of the state is related to the starting of the problem or stopping of the problem, and which of the state is related to the input or output or processing or decision making. So that means in order to handle the complex problems, to take the decisions, to guide the programmer that in which situation what step is to be done, the symbols are playing a vital role. So we need to clearly specify what symbols are for. Now there are advantages of the flowchart, that it relates to a proper communication, because a picture explains 1,000 words. So it establishes a proper communication. The programmer is able to understand what is to be done. The programming logic is well communicated with the help of the flowchart. Apart from this, the flowchart conveys effective analysis. That means the decision making is quite appropriate in the case of the flowchart, and with the help of the flowchart, documentation of the program is very much simplified. So it also relates to the efficient maintenance of the program and coding of the program. You need to understand that there is a difference in between a program and a software. Software is actually program included with the document, including the documentation of the program. So flowchart actually supports the documentation part of the program also, and it actually acts as an interface for the program to develop the documentation as well as to develop the code. So this is very advantageous tool for the programmer as well as for the documentation team of the software. But there are some of the limitations that when logic is highly complex, then drawing a complex logic become quite tedious. It is a complicated task. So at that point of time, we need to take care of other tools we will be discussing in other sessions. And alteration and modification of the logic in flowchart is again a problematic issue, because it is very straightforward, well-defined, crisp way to represent the logic of the problem. And reuse is not possible, that you depict the same problem in a different ways. It has got standardized format and it is represented in a well-defined manner. So these are some of the limitations. But so in order to consolidate, a flowchart is easy to write, and it is an easy technique to understand the logic. it has got easy identification of the mistakes by a non-computer person. By referring to the flowchart, even a person who is not having the computer programming background can identify that what went wrong and then what could be the possible solution. And this is the disadvantage, is that it is time consuming. You need to critically identify the problem, analyze and understand the problem, and identify that what possible symbols are to be used, and then you can design a flow chart. And it is difficult to show the bunching of the loops. There are various problems. We will be looking into those problems in the subsequent sessions, that when multiple loops are running into the picture, how it become problematic to manage those situations with the help of flowcharts. And big tasks are difficult to put into the algorithm. So if the algorithm is quite big and many decision problems are there, then drawing a flowchart become a tedious issue. So these are some of the advantages and disadvantages of flowchart. Now here is an example, finding a sum of 5 numbers. In fact, in the same picture, you are seeing that there is an algorithm, and on the right side we are having a flowchart. So these numbers are to be in fact entered by the users. So let's firstly understand what algorithm says. We are supposed to initialize a variable sum is equal to 0, and we are initializing a variable count is equal to 0. Then a number is requested to be entered by the user, that is number n is to be entered, and sum, that means you are supposed to find sum plus n and assign it to the sum, and increment count by 1. So why it is incremented by 1? Because first input is being given by the user. Subsequently, count is to be increased by 1, and it is checked that if count is less than 5, because 5 numbers are to be added, if it is yes, then you are supposed to go to 2. That means again next number is to be entered, and that next number will be added up into the number sum. Now reading into the lines and again analyzing each line what is to be done is quite tedious issue. Now let's see how this algorithm is mapped into a flowchart. We are using a symbol start, and we are clearly saying that some inputs are required, that is sum is equal to 0 and count is equal to 0, and we are initializing the variable sum is equal to 0 and count is equal to 0, and then we are entering in number n. Now entering in number n, we are adding a number n into the sum 0, which is initialized, sum equal to 0, which is initialized. So now new sum will be equal to n, and count will be incremented to 1. So earlier count was 0, so now it is 0 plus 1, that is 1. Now 1 is less than 5, yes, it again goes up and it requests again a next entry. Now next entry is say 2, so earlier n say 1, earlier n was 1, so sum was equal to 1, 1 plus 2 is 3, now count is equal to 2, 2 is less than 5, so again it will go up. And similarly, with the help of this loop, we are able to understand that this loop goes on again and again till the count is less than 5. The moment count becomes greater than 5, you say that count is not less than 5, so it comes out and it prints the sum. So I think you are able to understand that understanding of flowchart helps the programmer to write the code in a much better and efficient manner. Thank you very much.